Welcome back, everyone. Illustrate the direction of the dipole moment of the following indicated bonds. Use the symbols delta plus and delta minus. Let's start with the first structure. In the first structure, we're analyzing a bond between oxygen and iodine. For the purposes of this problem, let's recall that the electronegativity of oxygen is greater than the electronegativity of iodine. Oxygen is closer to fluorine, right? Fluorine is the most electronegative element. Let's recall that the dipole moment goes from a less electronegative atom to the more electronegative atom. So in this case, if iodine is less electronegative, then the dipole moment is directed from iodine towards oxygen. We're drawing an arrow, and we want to recall that delta plus means that electrons are further away from that element, meaning it's less electronegative, and delta minus means that electrons are closer to that element in a covalent bond, right? Electrons are not shared equally, so delta minus would always be on a more electronegative atom, meaning in this case oxygen would be delta minus or partially negative, and iodine would be partially positive, since the bond is polarized towards a more electronegative oxygen. And we can use the same principles to solve the second part of this problem. Specifically, we're given an ethyl group, CH₃CH₂Na. So in this case, we're analyzing a bond between carbon and sodium. Sodium is a metal, right? So apparently it will be less electronegative than carbon. So electronegativity of sodium is lower than the electronegativity of carbon, meaning sodium is expected to get a partial positive charge, and carbon is expected to get a partial negative charge because it's more electronegative. So we're going to add delta minus for carbon, delta plus for sodium, and of course, just as before, the dipole moment is going to be directed towards a more electronegative atom. And this is how we end up with our answers. Let's go ahead and label them. Thank you for watching.